Welcome back.
Yeah, so I'm Alex Wood from Analytical Graphics and Ed Mackey here, also from Analytical Graphics. We're here to continue our series on modeling the glTF authoring pipeline, so taking from a reference image all the way through Blender to a fully rendered glTF model. Previously, we covered building the geometry of this 3U Cubesat, and in here, we got as far as some placeholder materials, and if we stopped here, it's not really taking full advantage of glTF 2.0, right? Physically based rendering materials. And so that's the focus of this video, is we want to dive into material authoring in Blender. And Ed is pulling up the Blender documentation on the glTF exporter, which is a good resource to go to if you're deep in the Blender ecosystem. It talks about what sort of parameters we have at our disposal here for defining and authoring these materials. The big ones are base color. It's actually broken. There's a nice diagram on that exporter documentation that kind of breaks down different texture maps that we have available. There's a handful of factors that kind of tie in with each one of those layers that we have available. But high level, we have our base color, how metal parts are, how rough the roughness of those various facets on the model. There's an occlusion map for defining self-shadowing, which is a nice effect, goes a long way in your models. And normal maps is very common to 3D models. It kind of allows you to define how the light interacts with the micro facets on the model. So you can bake those details into the texture without having to have a lot of geometry backing that up, which is nice. There's an emissive channel too. We won't be using that on the Cubesat.
We don't have enough glowy parts on our Cubesat.
Right.
Maybe we need a circuit board with an LED or something.
Yeah.
Make use of the emissive channel.
So maybe stay tuned.
Okay, change of plans. No.
So Ed, back to Blender. I guess how do we get started here?
Okay. Well, we have our model geometry that we built last time. And just a quick reminder for those of you who skipped over that part because you already knew how to do this. We just simply built this model. The only interesting bit of it is that we have 4 flaps that are all instances of the same mesh. So we really only need to worry about texturing one of the 4 flaps, and the others are going to get copies of that texturing. And we also will obviously texture the body. And the other slightly unorthodox thing that we did is we broke out these blue pieces. These are all placeholder materials, but we actually broke out the blue solar cells as separate objects. And that's because we're hoping to bring this model into a package called SDK, where we might do some solar power calculation analysis. That is, it tries to figure out how much electricity is being produced from sunlight from hitting these things. And so we took the extra step of splitting them out into separate objects, which normally one would not do just for that reason alone, unless you were planning to use that particular tool. So to get into material modeling here, I'm going to head over to the shading panel. There are multiple different ways to do this. Let me zoom in. And overall, I would describe the different ways as saying either the image comes first or the UV atlas comes first. And then either the image comes first and you assign your UVs to match the image you got, or you can create a UV atlas first and then bake or otherwise create images to go with that UV atlas. And I hope to create videos that show both of those different workflows, but we're going to start with the simpler workflow, which is get the image first and then assign UV coordinates to it. So here on the shading panel, I see it's very bright and I don't like that, so I'm going to knock that down. And I have a default shader here. Let me zoom up on that. This is Blender's principled BSDF node. So BSDF being the, of course, bidirectional scattering distribution function.
I guess our audience probably knows what that is.
Yeah, you guys know all about that. If you don't know what that is, it basically means where the light goes. Mm-hmm. So the principled BSDF is a principled way of figuring out where the light goes. And I think they just didn't have room to write all that, or it sounds more technical if you use the BSDF terminology there. But this being the principled node, all of these different parameters are combined together in a principled way, I suppose. And some of these are rough equivalents for what's going on in the glTF file format. And so we're going to pick out those. We're going to skip over things like sheen and clear coat. Those are not in the current core version of glTF 2.0, but are maybe coming soon. But we're going to skip them for today, and we're going to do a simple material. So where does this image come from? Well, there's a lot of different sites out there. One of them, I'm not affiliated with this site, but I happen to like it. It's CC0 Textures. That's Creative Commons 0. It's the public domain equivalent license, which is a very, very permissive licensing. And I happen to like these guys. I'm going to search see if they have solar panels for me. And they do. Oh, look, here's one.
What are the odds?
What are the odds? And amazingly, I've already got it downloaded on my machine here.
Perfect.
Now, one of the things I like about this site and other sites that work like this one is that they give you more than just the color. This is more than just the color of these solar panels. It's actually giving me a normal map, a roughness map, a metal map. So I'm going to download all those, or I did download all those, and we're going to see if we can start installing some of them here in Blender. So first, let me make sure that I've selected the correct thing that I want to apply this material to. For now, I'm going to multi-select both the solar cells on flap 1, which will be automatically copied to the other because the other flaps are instances. And I've also multi-selected all of the solar cells down here on the body. And if we go to the material settings, you can see that these things all just share one material. It's the solar panel material that we created in the previous video. So let's go ahead.
You can actually see that blue color right next to the base color.
Yes,
on that node.
We can see the base color node there. And we're going to go ahead and add an image texture to plug into that base color. I'm going to hit open. We're going to go into CC0 Textures. There's the solar panel that we downloaded from that site. And I've got a couple of different maps here. I'm going to go with the color map for now, and then later on we're going to bring in these other maps. So let's hit open on that, and I'm just going to plug it right in and see what happens. So it did something, clearly. It put a few too many of them on each solar cell, I would say. Let's see why that is. Let me just organize my windows a little better here. I'm going to get rid of this thing at the bottom so we have a better view of our node graph. And here in this window, we will see our image. And you can see there's a lot of these on this image that we downloaded. So we're going to head over to UV editing and try and take care of this. Let's do select all and auto zoom. It looks like I've not gotten flap 1, so I'm going to go back to object mode and make sure that I've got the flap 1 panel selected. There's flap 1 over there. And then I'm going to control click the body solar panel. Let's get that turned on. And now we're going to go back into edit mode. Select all, yes. So now we have all of our solar cells selected, and they all take up the entire image, and each one gets a complete copy of that image on there. I don't want that. For now, because they're all together, I'm just going to take the easy way and scale them down. In a minute, I'm going to spread these out so that each one gets its own. But just for starters, I'm going to scale this down, try and get the right shape. I did a vertical scale there, and now we'll try and place this correctly. Sometimes it's a matter of fiddling around until you get kind of what you want, but that's kind of where I wanted that panel to be. And if you can see here, as I get close to my satellite, it's near plane clipping, of course. We built this model very small because it is a real Cubesat. So we have to fix our clipping planes to take care of that problem. And there we have it. And that is a per viewport setting. So every 3D viewport in Blender, you have to go and make that same setting happen. Otherwise, that's just going to keep happening. All right. So far, we only have the color map, and it's a nice color map, But if we can find a place where we catch the light or the reflection, there's not a lot going on. It's just a traditional texture map. There's nothing PBR about it yet. So let's see if we can get some other texture maps in there. I'm going to slide this up. And actually, I'll zoom up on this. And I'm going to hit Shift-D to duplicate. And so now I have another node. And in this node, I'm going to pull in the metallic image. The metallic image is a bit of a strange one. It's actually mostly white. Let's take a look at what that looks like. The metallic image is almost a pure white image. It's got just a few smudges over on the one side, but other than that, it is pure white. And this is something that I think you'll find is pretty common, is that most real-world materials are either made of metal or not. So things like plastics and ceramics, you would want to set this metal channel to all black. And for things that are metallic, you would set it to all white. And there's very little use of gray in there. And of course, it's monochrome, even though it says color. It's just a grayscale image. So we're going to plug it into metal.
So that dirt that's on the metallic map there.
Yeah, it's not mapped in yet because the dirt was somewhere over here.
It's probably a key indicator that these solar panels, the texture set wasn't meant for
it wasn't
clean
meant
room
for
solar panels.
Yeah, we need to spread these out, but let's put our material together and then we'll spread them out. One other thing I want to point out is that the color space of the metallic map, the color space of the roughness map, and the color space of the normal map, anything that's not a color, really needs to be marked as non-color. And the glTF exporter in Blender doesn't care and doesn't convert and doesn't bother to check what color space you have. But if you want to see the correct result in Blender, you have to set that color space.
I have seen it marked as linear before too.
Linear also works. It's a subtle difference between linear and non-color. My preference is non-color.
Right. The important thing is it's taking the color values and just handing it directly off to the material.
Yes.
No transformations.
Yes. And what you may find is that back on your download site, it looks like this, and you can see sort of blurry reflections with a few little facets here. And then you come over to Blender and you think, oh, that's great. I'll just I have this roughness map. Let's take a look. There it is. I'll plug in my roughness map. And then, oh no, in Blender, it doesn't look anything like what I thought I was downloading. It's way too shiny, and we're seeing reflections from a reflection environment that really we shouldn't be seeing on these panels. What happened? What did I forget? It's the color space. You can't leave it on sRGB for a non-color image. You gotta flip it, and then it will show you the correct thing in Blender. Now the glTF exporter will still create a model that looks like what you're seeing now in the preview window, regardless of what you set this to, because it doesn't care what you've set this to. But you will not be able to preview the correct thing in Blender unless you get these color spaces set correctly. It's very important. The other thing I'm going to show about this is that glTF has a very specific definition of which color channel is roughness and metallic. And I've blatantly disregarded that here. I've simply plugged in a grayscale image into metallic and a grayscale image into roughness. And the exporter does know how to handle that. And it will take those images and it will combine the color channels and write out the correct finished result as a result of doing that. If you don't want that, you can always check the manual and it will show you the correct wire up here in the glTF exporter manual page. It is the green channel that goes to roughness and the blue channel goes to metallic. And if you create an image that follows that pattern, especially if you've created a JPEG or something where you really care about the compression in the image, you don't want maybe the glTF exporter like decompressing and recompressing your image and fiddling with the color channels. If you wire it up in Blender in this way, then the exporter will stay hands-off and will just pass that image through. But I don't have such an image handy, so I'm just going to let the exporter take care of my color channel mapping here. And it seems to be doing okay so far. There's one more image that I can make use of. Sorry for jumping around on you. I'm going to hit duplicate on this, and we're going to grab one more image. That would be the normal map. And this one is also a non-color. The only ones that get the sRGB color space are the actual base color. And if you were to use that emission channel that we talked about to light up all your LEDs on your Cubesat, that would also get an sRGB color space because that is actual color going in there.
Right. So that's an important note for anyone who's developing a rendering engine. Your shaders, you do want to make sure that you're aware that those are in sRGB color space, because you'll have to convert those to linear.
Yes, and that's by glTF specification. You actually ignore the color space that's encoded in the image file, and you look at how it's being used by the model. And if it's being used for base color or emission or some other type of coloring, then you treat it as sRGB. Otherwise, you treat it as linear values. So I've added a new node here. I cannot just take this color, as you might hope, and plug a color directly into a vector socket. That's not going to produce a workable result. You see it seems to have kind of turned black on me there. You need this extra helper node going in here. And what happens on this helper node is that we take this image. This purpley image, it, by the way, is called a tangent space normal map. And it's this weird collection of purples and blues. And what you're looking at is actually not color there at all. It's vectors, X, Y, and Z, mathematical vectors.
Encoded into pixels.
Encoded, yes. So it's a whole set of axes per pixel. And it's describing the slope of the surface underneath. And there are different types of normal maps. There's object space and world space. glTF only supports tangent space normal maps. So when you do this, you're going to want to keep this on tangent space. And one of the things to consider here is that Blender really cares about this node tree, right? Blender is looking at material output, and it's building a shader based on all these wire-ups and computations. The glTF exporter has no nodes to work with. There are no shader nodes in glTF. What it's doing is it's looking for textures to plug into slots. It wants to find an image to plug into the base color slot. It wants to find a metallic roughness image with paired up green and blue channels to plug into the metallic roughness slot in glTF.
Right. So it's not going to, when the exporter is not going to take your source images and just drop them in a folder, it's actually going to rebuild its own optimized images where all the channels are packed.
It does try to preserve existing images. Like if you've given it an image, especially things like base color where it doesn't need to change the color channels around, it will try and preserve the actual bytes of the image you gave it. Particularly in the case of JPEG, you don't want it like decompressing and recompressing your JPEGs. And likewise with the normal map, the exporter doesn't care that there's this normal map node here, other than it's using the normal map node to find the correct image to stuff into the glTF file. It does care about the strength setting. That there is a corresponding normal strength setting in glTF that will get copied.
So can we take a look at the normals and?
Yeah, let's see what that map did for us. I'm actually going to change that strength setting so we can see what this normal map is doing for us. It distorts the apparent surface. So we know this is a single flat polygon, but it looks all bumpy and distorted. And we can control from the strength setting how strong that distortion effect is.
So, are those JPEG compression artifacts there?
They probably are.
Okay.
Thanks for pointing that out. Once you learn how to see JPEG compression artifacts in a normal map, you will never unsee it. So thanks to Alex, you will always from now on be able to recognize JPEG compression artifacts when they appear in normal maps. And you'll get mad at every 3D model that does this from now on. Congratulations.
Yes. Happy to help.
So we have the basic skeleton of a glTF-friendly material here. And this arrangement of nodes is not going in the glTF file. The arrangement of nodes is here to sort of tell Blender how to preview this glTF material. And it's also there to tell the exporter what all images it needs to go find and encode into this glTF file. So that's our solar panel. Let's go back to layout And it looks a little dark here in layout land, but if you remember in the first video, we actually picked a very darkened environment because we had those placeholder materials. I'm going to switch to, what do you think? Maybe one of the, wow, that one, that's a nice bright environment there. So you can try it out, and you'll find your models look very different in different color environments. You should try and pick a few and make sure it looks good. And remember, of course, if you're headed for SDK after this, especially if it's a satellite, your thing is going to fly in space. It's actually dark in space, like really dark most of the time, unless you're in sunlight. So the lighting environment is extremely harsh, and unfortunately, you sort of have to build your model with that in mind, that you still want it to look good, even in those extreme lighting environments. So let's see if we can export this. One of the things I want to do, we have this little spin 90 guy here. We used that with an array modifier while we were building this, but the array modifier is long gone, and the spin 90 is not needed anymore. I'm going to delete that. I am going to save this project. And for now, I'm going to turn off the light and turn off the camera. And I'm going to hit A to multi-select everything else, which is all the different parts of our Cubesat. And so with them selected, with all those parts selected, we are now going to export. So here's our glTF exporter. If you were exporting these separately, you would create a folder. I almost always export these into a folder. I almost always tell it to remember the export settings too.
And I see we're going to export as a GLB.
I think, yeah, for this first go, we're going to export a GLB.
All right, so that's the bundled version where all the textures are packed into a single asset. So if you want to share this model, there's only one file you have to worry about.
Right. And it makes the model easy to share when it's a single binary bundle. It makes it more difficult to pick apart and look at the interior of it, although there are still ways to do that. I'm going to also tell it to export only the selected objects. That'll be more important later. I mean, the camera and the light are, if they got exported, it's no big deal. But later on, maybe in the next video, I might have baked targets or something. And for this one, I am going to apply modifiers because if you recall in the first video, I did a lot with that auto smooth stuff going on. And there's an implicit edge split modifier that happens that needs to get applied. And again, what happens there is glTF is really trying to get this data as ready for a GPU as it possibly can be. So you can't have vertices that are sharing sharing faces but not sharing normals, because that's not how the raw data is when it gets loaded onto a GPU. So it's going to get this data all triangulated and the vertices split apart and get it really ready to put onto a GPU. So as soon as somebody receives this file, it can go straight into the rendering.
Would you say it's generally recommended to always have apply modifiers checked when you're exporting?
For a satellite like this, yes. If you're doing a skinned model, a mesh with an armature, there's like an armature modifier, and you can't hit apply modifiers in that case. It will mess up your armature and your skinned mesh. But we don't expect this Cubesat to go walking away on us, so we're pretty reasonably safe there. So let's see what it saved out here in our glTF folder. It made this little file. I didn't do anything about optimizing the textures, so they came out a little large. But I just hit the Enter key on it. I'm on Windows 10 here, and the viewer came up. You can actually right-click one of these, and you can open it with a 3D viewer. And Windows 10 actually knows how to do the real PBR surfacing on this model. So we got a nice export here. Of course, we have placeholder materials, but as far as the solar cells are concerned, they
look pretty good.
They look pretty good. They came out correctly, or at least they came out very similar to how they looked in Blender. And so it looks like they're going to survive in other packages, and they should load in SDK pretty well.
Okay. So I guess just to recap, right? You walked us through actually downloading an existing texture set that had all the physically based textures that we care about with glTF 2.0.
That's right.
That's not always the case. Sometimes you might have to author your own materials, either procedurally or through some photo manipulation tool like GIMP or Photoshop.
Or Substance Painter.
Or Substance Painter. And we'll cover, I guess we'll cover that in the next video.
So in a future video, I hope to cover procedural baking of materials. And also in a future video, and I'm not sure the order of them yet, but I also hope to cover loading this into SDK and adding articulations to it.
Perfect.
There it is.